Hello everyone, in this video I'll be explaining the problem, the best card. So this was asked in educational code forces round 193 rated for division 2. So let's read out the problem. In a card game, there are n cards with values starting from 2 up till n plus 1. So to determine which of two cards with values x and y wins, apply the following rules. So if one of the numbers x and y is divisible by other, the card with the smaller value wins. Otherwise, the card with the larger value wins. Okay. For example, between card 2 and 6, since card 2 wins because uh, 6 is divisible by 2. Between card 4 and 6, card 6 wins because neither of these numbers is divisible by other. So determine whether there exists a card that wins against every other card. Okay. So we have learned test cases and we have been n which is from 2 to 10 power 5. Okay, so yeah, let's take out some of the examples and understand. So the problem name is the best card. So in the problem they'll give n, and this n ranges from 10 power 5. Okay, basically what they said is when they give n, so there are n cards and the numbering of the card are from 2 up till n plus 1. Basically, let's say when they've given n is equal to 4, so your card will have, it will start from 2, 3, 4, and then n plus 1, 5. So we have 4 cards. Okay, and what that's asked is we need to choose two integers x and y, let's say, and the minimum of x comma y, whatever we have, since here we don't have duplicate elements, so there will always be minimum, unique minimum. Okay, so minimum of x comma y indicates if this card wins when one of the number is divisible by other. You can say or y modulo x is equal to 0, and the number x comma y wins, I mean the higher card, when neither numbers divide it. Okay, so these are the cases. So in the question what they've asked is find the card which is so we need to determine there exists a card that wins against every card. Okay, which wins against every card. So we need to find that card. So basically, if you understand test case, let's say n is 2. Okay, so this is the bare minimum card that we'll have. So when n is 2, you have card with number 2 and 3. Okay, now if you try to take, since there are only two cards, you take 2 modulo 3. So so it is giving you modulus as 1. It is not equals to uh, you know it is not equals to 0. Similarly, if you do 3 modulo 2, again here modulus is giving 1, so it is not equals to 0. So in this case, if you see which one is winning, the card 3 is winning, because since they are not divisible by one another, so the higher card will be winning. So in this case the maximum is 3. So and 3 can win against only card number 2. So it has only one card, so it is winning. So definitely, um, in this case, what we need to return? We need to return yes. There exists a card. There exists a card which is winning against all the card. Okay. Now if you consider NS3, so you'll have card S2, 3 and 4. Three cards you have. Okay. Now if you try to take card 2 as winning, so what we'll have to do is we'll have to pair with 2 and 4. So now 2 and 3 if you are doing, so 2 modulus 3, it is giving you 2. Here also it was 2 only. I think yeah, it is 2, not 1. Okay, it is not equal to 0. And if you consider 3 modulus 2, again here it is giving 1, it is not equal to 0. So which means you can say between 2 and 3 the card 3 is winning because it is not divisible, so the higher card will be taken as the winning card. So in case if we are considering 2 number card for winning, so it is not possible because it is losing against card 3. Okay, now let's try to take 2 as 3 as winning. When you take card 3 as winning, so now since we have already compared 2 and 3, so 3 is winning already, you're saying. Now let's compare 3 and 4. So 3 modulus 4 if you do, so answer is 3, it is not divisible. And when you find 4 modulus 3, it is 1, and also it is not divisible by I mean basically it is not divisible. So since they are not divisible by any these 3 and 4 not divisible by one another, so in this case the higher number card is winning, basically 4 is winning. Okay, so we can say 3 is also not winning. Okay, and it is losing against, it is losing against card 4. Okay, now we have got now let's take, you had card number is 234. Let's take card number 4 as winning. When you take card number 4 and is winning, you will be comparing it 4 and 2. Since you have already compared here 3 and 4, these two you have already compared, and you have got that 4 is winning, but you need to check with the other card as well, which is 2. So if you do 2 modulus 4, it is 2, which is not equal to 0. Okay, but we need to check now 4 modulus 2, other way around, so it is 0. Okay, which is equals to 0. So which means among card 2 and 4, they are divisible. Okay, they are divisible. Since they are divisible, so the lesser value of the card is winning. Okay, here 2 is winning, which means you can say when we consider card 4 as winning, so it is not winning all against all other cards. So in this case 4 can also be um, not a card wherein it is winning against all the cards. So we have considered all 3 cards. So in this case we have seen no card is winning against all other cards. So in this case answer will be no. Okay, so I think you're getting. Similarly, if you take NS5, okay, when you take NS5, now you have already checked with 2 3 4 above, right? When you have checked 2 3 4 here, so they are not winning each other. So this 2 3 4 cannot be a winning cards. Now let's consider 5. When you consider 5, now we need to check in against all the other. So when you take 2 and 5, so their modulus are they can't divide each other basically. Okay, they can't divide each other, so 5 is winning, we can say. Similarly, if you take 3 and 5, again they are not divisible by each other, again 5 is winning. And take 4 and 5, so again here what will happen is, um, they are not divisible, so 5 is winning. But now these three, against all these three, 5 is winning, but let's check against 5 and 6. When you check again 5 and 6, again they are not divisible, but here 6 will be winning according to the condition. So if they are not divisible by each other, so the higher card is going to be win. So again what here it is happening is, we have taken card 5 against all other cards, so it was winning against the previous cards, but it is not winning against 6. When you now consider 6, okay, 6 is winning, 6 will be losing against 2, because 6 modulo 2 is giving you 0, okay, which means it is divisible. When it is divisible, so definitely smaller card is winning. So 6 is losing against 2, so 6 cannot be. So in this case also we don't have any answer. So one thing you have to note down is that when we have taken 5, okay, it was winning against all other cards. This is one of the crucial observation. So now let's take ns4. When you take ns4, your cards are this, and you have already seen among 2 3 4 no card is winning, but against 5 you have seen here it was winning against 2 3 4. Okay, so definitely this 5 can be a winner in all other I mean when it does an operation with all other cards. So in this case definitely we have an answer. So so again let's take other example. When n is um we can take 6, so we have 2 3 4 5 6 and then 7. We have 6 cards, and now in this case we have, as we have already seen, 2 3 4 against 5 will not win. I mean 5 will be winning against these two. But when you consider 5 and 6, since it is not divisible but 6 is greater, 6 is winning, so 5 cannot be your answer. When you consider 6 now, 6 is losing against 2, so this cannot be. But when you consider 7 and it's a prime number, this is the crucial observation. Okay, it is a prime number. Since it is a prime number, it will not be divisible by its lower numbers. Basically whatever number card we have and it is a prime number, it will be not divisible, and it is obvious. Okay, the definition of prime number says it is divisible by itself and 1. So since card is not starting with 1 and it is starting with 2, so all other lower numbers um, you know will not be divisible. And in that case, since 7 is greater, highest, so it is going to win. So in this case when it is written, yes. And the other example we can take is when n is 8. Okay, okay, so this even number whatever we have, okay, even number of cards, let's say you take 4 6 and 8 and whatever we have 2, so this will not be an winning card. The reason being, 2 can divide 4, so it can win. 2 can divide 6, it can win. 2 can divide 8 and 2 can win. But when it comes to other numbers like 3 5, in this case it is not divisible, so definitely a higher number is going to win, and 2 is the smallest possible card we have. Okay, so now when you consider other odd numbers, what will happen is, the it may happen that when this odd number is prime, so the lower it is will not be I mean, it can win with the lower one, but it cannot win with the higher one. The reason being, since the higher cards have a value more and it is not divisible, so definitely higher cards are going to win. Okay. Similarly, when you see 7, 7 is also a prime number, so it is going to win. But since we have 8 and 9, it cannot win against 8 and 9. But when you consider again one more odd number, 9, now here what will happen is it is not a prime number, so definitely your answer will be no, and I'll tell you why. Because when you consider 3 and 9, so 9 modulo 3 will give you 0, which is divisible. So in this case, 3 is gonna win. So 9 is not winning against 3. So 9 cannot be our winning card. So whenever your n plus 1 is prime number, so I mean, we should print yes, because the n plus 1th card is a prime number and it is winning against all other cards. Okay. And the other case is like no, in all other cases it will not be divisible. So I think I've understood now. If you try to write algorithm, what will happen is we'll have to basically check n. If is prime, you can say if n plus 1 is a prime number, then our answer will be yes, else our answer will be no. Okay. So that's it. So how do you find prime number now? We can find prime number using square root method. So basically you need to travel from 2 to square root of that number, square root of n plus 1, and if any number from 2 to square root of n divides n plus 1, okay, any number, let's say I, if it divides the number n plus 1, then it's not a prime, else it's a prime number, we can say. So yeah, that's it. So let's go to VS Code and try to solve it. So we have input as just n. For every test case I'm handling at this position. So for every test case I'm calling a solve function, and we have n. So we need to find if is prime of n plus 1. If n plus 1 is a prime number, then definitely n plus 1 card will be the winning one, because all the lower cards will not divide this number. So in this case we need to print yes, else we need to print no. Let's add this prime function. So since the number cards is starting from 2, so we don't need to check for n equals to 1. Okay, so directly we can do is we can call a loop, and it will start from 2 and square root of n till we'll go till square root of 1. I will have to check if this n modulo I equals to 0, which means I number divides n. So in that case we need to return false, it is not a prime number. Else when we come out of the loop, no one divides, then we can say it's a prime number. So sample test case is passing. Let's try to submit and see. So it's in a queue right now, but yeah, it will get accepted because in the contest it was getting accepted. So you can see it got accepted. So that's it about the problem statement. And if you try to analyze the time complexity, so we are calling just prime function. So this prime function is running for square root of n times. So yeah, that's it, the time complexity, and space complexity is constant. So thank you guys for watching the video.